Right, use the binomial theorem, expand 3x plus 2 cubed, simplifying each term of the expansion. Now, with the binomial theorem, we can use Pascal triangles to determine the coefficients. Okay, so remember, we start with 1 at the top, okay, and then 1 either side, all right? And the principle is you add the two numbers above to the left and right, okay? So, you know, for instance, this number here, is 1, because if you look above to the left is 1 and to the right there's nothing there, so it's just 1. And the same here, if you look above you've got 1 to the right and nothing to the left, so it just adds up to 1. And when we go on to the next line, we have the same principle. It'll be 1 here, because if you look above to the right you get 1, to the left is 0, so it becomes 1. But in the center here we can have 2, of course, aren't we? Because if you add the two numbers here to the left and right above it, it adds to 2, and of course we'll have 1 there at the end. We need to go one more row because power 3, okay, and we need to have the 3 appearing here. So if I go one more row, I have 1 at the end here again, because you've got 1 there and nothing here. Add them, you get 1. 1 and 2 make 3 here, so the 3 appears, yeah, so that means we've got the row that we want in terms of getting the coefficients, and 3 here if you add these, and 1 at the end. So when we want to expand this here, this bracket cubed, first thing I do is write down the general formula. So a plus b cubed, okay? And if you remember, okay, we use these coefficients here. So the first coefficient is always going to be 1, all right? And then we start with our first term to that power, so it'll be a to the power 3, okay? So you always start with that to the highest power, and b to the lowest power, so it would actually be b to the 0, but we don't need to write b to the 0, because anything to the power 0 is 1. So then we add, now the next coefficient is 3, so I'll write 3 here. Then we're going to have a, right, again, but this time now we reduce the power. So it was a cubed there, it'll be a squared here. So we reduce the powers of a, but we increase the powers of b. So here's b to the 0, next is going to be b to the power 1, plus then the next coefficient, which is 3. So, and then we continue reducing the powers of a, so a cubed, a squared, so it'll be a here. B's we increase, so b0, b1, b squared. And then, last but not least, the coefficient at the end then is 1, as we'd expect. It'll be a to the power 0, because yeah, we've got a cubed, a squared, a to the power 1, a to the power 0, which we don't need to write. And the b's are increasing, and so b0, b1, b2, b to the power 3. So there's our general formula. What we do then is we substitute in the terms that they've given. Okay, so in a sense then, your a becomes 3x, your b becomes 2. So we literally put them in there. So 3x cubed, okay, for the a there, it becomes 3x, plus then 3, a is 3x squared, and then b, which of course becomes 2. Okay, so I use brackets for substituting because it's much clearer. And then we've got plus 3 then, a then, which of course is 3x, and b, which is 2, so it'll be 2 squared. And then finally then the b at the end of the b cubed, so b is 2, so it'll be 2 cubed. Okay, so final answer will become, well, if I cube this, remember we've got to cube the number as well, so it'll be 27x cubed. Take our time on this. Perhaps what we could do is do 3 times 2 first, multiply the ones at the end. 3 times 2 is 6, and in the bracket, when you square that, you get 9x squared. Plus then, we could do the same here, 3 times the number here if you want, because that would be 4, wouldn't it, when you square that. So 3 times 4 is 12, keep that in the bracket, and then 2 cubed is 8. So we finally get then 27x cubed, 6 times 9 is 54, 12 times 3 is 36, and then plus 8 at the end, and we're finished.